Yes.
Assalamu alaikum, everyone. Today, we are starting an important topic in biochemistry, that is body fluids. This topic forms the foundation for understanding how the human body maintains internal stability, or what we call homeostasis, right? For BDS students, this is particularly important because body fluids like saliva, plasma, and interstitial fluid directly influence oral health, inflammation, drug delivery, and healing processes, right? So, dear students, I want you to stay focused. This lecture will connect basic biochemistry with the real clinical understanding of your dentistry, right? So, the topic is body fluids. Let's start with a quick thought-provoking question. Which body fluid do you produce the most in your lifetime?
Saliva.
Okay. Any other answer?
Blood.
Mucus.
Okay. Okay. And here is the riddle, right? I can signal love, wash away dust, and spill when, emotions combust. What am I?
Water.
Ears.
Water.
Okay.
Ears.
Okay. Tears. Okay. Okay. Perfect. No. Okay. Okay. Now, why did I start with this, right? Because it reminds us that the body fluids are not just, biological substances. They are functionally specialized. So each body fluid in the body has a unique role, either protective, either emotional, either digestive, or a regulatory function, right? Got it? So let's move to the learning objective of this session. By the end of this lecture, you should be able to clearly understand several key points or key concepts. Like the very first one, describe the concept of pH, pH scale, acidity, basicity, weak acids, and their conjugate bases. Furthermore, describe the importance of Henderson-Hasselbalch equation. All you need is to, describe the importance of Henderson-Hasselbalch equation, not the derivation. Derivation is not required here, right? The next one would be describe or define the relationship between pH and concentration of conjugate acids and bases. You need to remember no derivation of Henderson-Hasselbalch equation is required. Furthermore, you need to name the different buffers present in your body, right? And later on, you need to describe the role of the buffers in controlling the body pH. All right. At the end, we should be able to describe the distribution of body fluids in various body compartments. Furthermore, differentiate between intracellular and extracellular fluids. फिर कुछ definitions आएंगी. Define and describe the surface tension, viscosity, and osmosis, and their clinical implications. All you need is to provide or describe the role of these physicochemical properties in body fluids in your human body, right? इनकी मजीद डिटेल्स हमें बहुत ज़्यादा डिटेल्स हमें नहीं चाहिए. All you need is to describe the clinical implication of these physicochemical properties, right? What about the learning resources you can use for this? You can use learning resources like for this lecture, the main reference include that would be Chatterjee, Mushtaq, and the standard lecture notes, right? I strongly recommend that after this session, you go back and revise these new concepts from your textbook, especially the diagrams and tables, right? Because they are, frequently tested in exams. Let's start with some of the very basic definitions, right? What is an acid? How do you define an acid? An acid is a substance that releases hydrogen ion in its solution, right? And what is a base? A base, on the other hand, is a substance that accepts hydrogen ion. This concept is extremely important because hydrogen ions directly affect protein structures, enzymic activity, and overall metabolism. Even a small change in hydrogen ion concentration can significantly change or disturb normal physiological functions, right? So let's move to the acid and bases and its types, right? Okay. As you know, acid is a component that got the property to donate its hydrogen ion. What is the, strong acid and weak acid? Strong acid completely dissociate into its ions, anions or cations, even in strongly, in a strongly acidic solutions, right? So some of the examples are the hydrochloric acid and sulfuric acid. What about the weak acids that partially dissociate into its components? Acetic acid is an example. What is a strong base? Strong base is basically, completely that can dissociate completely into its components, right? Potassium hydroxide, sodium hydroxide is an example. And what about the partially dissociate component of a base? That is, you can label it as a weak base. Calcium hydroxide is one of the example of that weak base, right? Let's move to the next component, that is conjugate base. Conjugate base को कैसे define करते हैं? When an acid loses its hydrogen ion, it forms what we call a conjugate base, right? When an acid loses its hydrogen ion, the remaining component would be the conjugate base. For example, hydrochloric acid loses its hydrogen and becomes chloride ion. So this is one of the example. This relationship between acid and conjugate base is the basis of buffer systems, right? Buffer systems work by either donating or accepting the hydrogen ions, depending on the situation, right? So conjugate base को define कैसे करते हैं? A conjugate base is basically an acid, right? Is an acid minus hydrogen ion, right? So that is a conjugate base. Let's move to the pH concept, right? pH is basically how you define a pH, right? pH is a measure of hydrogen ion concentration in a solution, right? It is expressed as negative log of hydrogen ion concentration. The pH scale ranges from 0 to 14. Values below 7 indicate acidity, while values above 7 indicate alkalinity or basicity. One important thing to remember is that pH is logarithmic. So even small changes represents large shift in hydrogen ion concentration, right? So this is the equation. pH is the negative log of the hydrogen ion. All right. Okay. If the human body, in the human body, normal blood pH is tightly regulated between 7.35 to 7.45, right? So this is the normal range of the pH of the human body fluids, right? 7.35 to 7.45 is the normal range. If the pH drops below this range, the condition would be called as acidosis. What is meant by acidosis? If the pH drops below its range, below 7 towards 0 agar jata hai, so that becomes acidic medium, right? And if it rises above its range, right, so that becomes alkalosis, and the condition would be called as alkalosis. Both conditions can severely affect enzymic activity, either alkalosis or acidosis. Both can affect the enzymic activity in a greater terms, right? So in order to manage the cellular metabolism and organ functions, you need to have a tight regulation of the pH within a minute range, that is 7.35 to 7.45. In fact,
Sir,
extreme.
can you repeat alkalosis?
I'm sorry.
Could you repeat what you said about alkalosis and the other thing that you said?
Okay. If the pH of the body, if the body fluid, the range of the pH is around 7.35 to 7.45, that is neutral, right? Got it? This is a normal pH of the human body, right? If the pH drops below its range, 7.35 से नीचे अगर drop कर जाती है, तो that becomes acidic, right? And the condition would be acidosis. And if it rises above its range, it is called as alkalosis, right? More than 7,
Okay.
that is alkalosis. And if it is below 7, that the medium would become acidic and the condition would be acidosis. Correct?
Yes, sir. Thank you.
Okay. All right. Next is, okay. So water has, pH of 7 and is considered as neutral, right? Right? And the pH of your arterial blood is normally between 7.35 to 7.45. Right? The more the alkaline a solution, higher will be the pH, right? The condition would be alkalosis. The more the acidic a solution, the lower the pH, and the condition would be acidosis. Correct? Next is the dissociation constant, right? The strength of an acid is measured by its dissociation constant, the Ka value. The strength of an acid is measured by its dissociation constant. The larger the Ka value, means the acid dissociation more, and therefore it's stronger the acid would be. The more the acidotic condition would be, right? Right? The smaller the Ka value, it means the weaker the acid, right? Right? In biological systems, we often use the notion, the pKa, right? Which help us to understand the buffering capacity. Stronger the larger the pKa value of a component or an acid, the stronger it would be, right? The lower the pKa, the weaker the acid would be, right? Right? And this is the equation. You can refer to this, the dissociation constant, right? 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 Is it clear?
Yes, sir.
Yes.
All right.
Yes, sir.
Okay. Next is the Henderson-Hasselbalch equation, right? Henderson-Hasselbalch equation. This is one of the most important equation in biochemistry, right? It relates pH to the ratio of an acid or conjugate base. The concept here is that pH depends on the ratio between the two components, not just their individual concentrations, right? So this equation is widely used in clinical practice to understand the acid-base relationship. So Henderson-Hasselbalch equation is basically a quantitative relationship between pH of a solution and weak acid plus its conjugate base, right? So Henderson-Hasselbalch equation is basically a quantitative relationship between pH of a solution and the weak acid plus its conjugate base, right? So this is the final equation that is basically representing Hasselbalch equation, Henderson-Hasselbalch equation, right? pH is equal to pK plus log of A minus over HA, that is basically a weak acid over conjugate base, right? So this is the equation you have had, in your previous slide, that representing the pKa value, right? pKa, right? Okay, let's come to the application of Henderson-Hasselbalch equation. As you know, as you can see from the equation, this on the bottom of the slide, representing the Henderson-Hasselbalch equation, right? pH is equal to pKa plus log of the conjugate base over a weak acid, right? Correct. So you can find both of these or all of these components, by having or by missing any one of the component, by having all the corresponding values. If you want to find out the value of pH, right, all you need is to have the value of pKa, conjugate base, or weak acid, right? So very first application, right, you can calculate the pKa value from the pH, right? आप क्या कर सकते हैं, अगर आपने pH की वैल्यू नोट करनी है या कैलकुलेट करनी है, तो आपको क्या चाहिए, pKa वैल्यू चाहिए, प्लस आपको वीक एसिड का पता होना चाहिए और कॉन्जुगेट बेस का पता होना चाहिए, राइट? सो दिस इज द वेरी फर्स्ट एप्लीकेशन, करेक्ट? ठीक है यहाँ पे। ओके, नेक्स्ट आगे चलते हैं। अगर आपको कैलकुलेट करना है, इफ यू वांट टू फाइंड आउट द वैल्यू ऑफ pH, राइट, तो आपको किसकी वैल्यू पता होनी चाहिए, pKa की वैल्यू पता होनी चाहिए, कॉन्जुगेट बेस पता होना चाहिए, और आपको पास वीक एसिड का की कंसिडरेशन आपको पता होनी चाहिए। यू कैन फाइंड आउट द वैल्यू ऑफ pKa और pH, एंड along with you can find out the value of either the weak acid or the weak acid or the conjugate base as well, right? आपको इस इक्वेशन से आपको क्या पता चलता है कि आपको अगर कोई एक भी वैल्यू किसी भी इक्वेशन में, किसी भी केमिकल रिएक्शन में, आपको कोई एक वैल्यू, आइदर यू वांट टू कैलकुलेट द वैल्यू ऑफ pH, pKa, either you want to calculate the value of conjugate base or weak acid, तो आपको बाकी कंपोनेंट्स की अगर वैल्यू पता है